Hello, young explorers. Welcome back to Curiosity Corner, where we journey through the mysteries of the cosmos and the wonders of science, all in a day's adventure. From the fiery storms of our sun to the deepest secrets of black holes, get ready to explore how our universe works and why it's even more incredible than we imagined. Let's go. Imagine the sun, our life-giving star, suddenly sending out a colossal burst of energy, a solar storm so powerful it can reach all the way to Earth. These bursts are called coronal mass ejections, or CMEs. They are huge clouds of charged particles and magnetic fields hurled from the sun's outer atmosphere, the corona, traveling at speeds over 1,700 kilometers per second. When a CME is aimed directly at Earth, it can slam into our planet's magnetic shield, causing what scientists call a geomagnetic storm. During a geomagnetic storm, Earth's magnetic field is disturbed, sometimes opening up like a door to let solar energy pour in. This can create dazzling auroras, lighting up skies far from the poles, even as far south as New Mexico. But these storms can also disrupt our technology. Satellites may lose data, GPS signals can falter, and power grids might suffer outages. That's why scientists watch the sun closely, ready to warn us when a monster solar storm is on its way. So, while the sun's storms are a spectacular natural show, they remind us how connected we are to our star and how important it is to understand and prepare for its powerful moods. But understanding the sun's wild moods doesn't stop with solar storms. High above, on the International Space Station, a clever tool is helping us look deeper into the sun's blazing outer layers, where space weather begins. The sun's outer atmosphere, known as the corona, is a place of constant motion and mystery. But how do scientists watch this blazing, turbulent region? Enter NASA's CODEX, the Coronal Diagnostic Experiment, a remarkable instrument aboard the International Space Station. CODEX uses a clever trick. It blocks out the sun's bright face with tiny disks, creating an artificial eclipse that reveals the faint corona. Unlike earlier tools that only measured how dense the corona's material is, CODEX can now tell us how fast the solar wind is blowing and how hot it really is. By comparing light through special filters, CODEX paints a detailed picture of the sun's sputtering gusts of hot plasma. This is vital because the solar wind, a stream of charged particles flowing from the sun, shapes space weather that can affect Earth. With CODEX's new insights, scientists can better predict solar storms that might disrupt satellites, power grids, and communications. Understanding the sun's moods helps us protect our technology and keep our modern world running smoothly. So, thanks to NASA's CODEX and other space weather tools, we are no longer in the dark about the sun's secret storms. While scientists study the sun to predict space storms, others are peering into the tiniest parts of reality, using quantum physics to create something we all rely on: true randomness. Imagine a world where chance decides who will serve on a jury or who wins a lottery. Behind these moments of fate lies something very special: random numbers. But how can we be sure these numbers are truly random and not rigged or predictable? Today we explore the magic of randomness and how scientists use the strange rules of quantum physics to create numbers that no one can cheat. Most computers create pseudo-random numbers, sequences that only seem random but can be guessed if you know the pattern. To make truly random numbers, scientists turn to the quantum world, where tiny particles behave unpredictably. By measuring pairs of entangled particles, whose properties are mysteriously linked, they generate numbers that are impossible to predict or fake. This clever system uses multiple independent checks, like cryptographic fingerprints, to ensure no one can tamper with the results. So whether it's picking a jury or drawing a lottery, these quantum random numbers keep the game fair and square. And just as quantum particles reveal surprising truths on a tiny scale, the universe also puts on breathtaking shows on the largest scales, like when two neutron stars crash together to forge the brightest explosions in space. Imagine two incredibly dense stars, called neutron stars, locked in a cosmic dance. These stars are the remnants of massive stars that exploded long ago, each packing more mass than our Sun into a tiny sphere just 20 kilometers wide. As they spiral closer, their gravity pulls them faster and faster until at last they collide in a spectacular cosmic event. From this violent merger, a black hole is born. The lighter star is torn apart, forming a swirling disk of matter around the black hole. This spinning disk, combined with the black hole's own rotation, twists and stretches magnetic fields to enormous sizes. These magnetic fields then shoot out powerful jets of energy from the poles, traveling nearly at the speed of light. These jets shine as gamma-ray bursts, the brightest explosions we know in the universe. Scientists use supercomputers to simulate these incredible collisions, helping us understand how such enormous magnetic fields form and launch these dazzling jets. By studying these cosmic fireworks, we learn more about the most extreme events in our universe and the forces that shape it. From solar storms and spinning stars to quantum mysteries, science is always unveiling new wonders, big and small. And the more we explore, the more we realize the universe isn't just full of secrets, it's full of stories waiting to be told. So stay curious, young explorers, and see you on the next Curiosity Corner.